In our experience, time is the invisible foundation of everything we do. It is the steady heartbeat of our lives, ticking away seconds, minutes, and years with a rhythm that feels absolute and unchangeable. We trust time because we have no choice. It is the medium in which we are born, learn to love, and eventually die. But could this trust be misplaced? Sadly, according to the most cutting-edge theories in modern physics, our perception of time might be nothing more than a biological hallucination. Time as we know it, this comforting flow from yesterday to tomorrow, might not be a fundamental feature of reality at all. Instead, it could be a temporary hologram destined to evaporate, leaving us with a static, frozen eternity where now loses all meaning. This scary idea wasn't something that kept Isaac Newton awake at night, but today, it terrifies those who understand the mathematics of the universe. If the calculations are correct, time is not a safe harbor. It is a volatile, treacherous dimension that can stop, loop back on itself, or even vanish entirely. In this video, we are going to confront the 16 most disturbing paradoxes of time. We will start with the deceptive simplicity of relativity, descend into the madness of the quantum realm where the future can rewrite the past, and finally face the ultimate cosmic nightmare, the heat death, where time itself dies. We will examine why your intuition about the flow of moments is wrong. We will look at why physicists believe that your past is not gone, and your future is already carved in stone, waiting for you to arrive. By the end of this journey, you might look at the clock on your wall not as a tool, but as a mask hiding a much colder, stranger truth. The question isn't just whether time will end. The question is whether it ever truly started. Before we can understand how time breaks down, we must understand why we think it flows in the first place. For centuries, most scientists and thinkers believed that time was like a divine metronome. Isaac Newton, the father of classical physics, described time as an absolute vessel. In his view, a second on Earth was exactly the same as a second on the Sun or at the edge of the galaxy. The universe was a giant, perfectly synchronized clockwork mechanism, ticking forward at a steady pace, regardless of what happened inside it. This view is comforting. It matches our daily experience. But in 1905, Albert Einstein shattered this clock forever. Einstein showed that the universe is not a rigid mechanism, but more like a chaotic ocean. He revealed that time and space are woven together into a single fabric, called spacetime. And just like a fabric, it can be stretched, twisted, and torn. Einstein's theory of relativity implies that time is personal. It doesn't march to a single drumbeat. It reacts to matter and energy. It flows differently for you than it does for a GPS satellite orbiting the Earth, or for an astronaut falling into a black hole. Time can slow down, speed up, or act in unexpected ways depending on how you move and where you are. This realization opens the door to paradoxes that challenge our sanity. If time is flexible, then the barrier between the past and the future is not as solid as it seems. It implies that now is a relative concept, a local illusion rather than a universal truth. While Newton gave us a universe of certainty, Einstein left us with a universe of vertigo. And as we peel back the layers of this theory, we find that the flexibility of time allows for scenarios that seem logically impossible. Scenarios where causes happen after their effects, and where you can become your own ancestor. Let's start with the most famous crack in our understanding of time, the twin paradox. Imagine two identical twins, Alice and Bob. They are the same age, down to the second. Alice is an astronaut who boards a spaceship capable of traveling at near the speed of light, while Bob stays behind on Earth. Common sense tells us that when Alice returns, she and Bob should still be the same age. After all, time is time, right? But relativity dictates a grim difference. As Alice accelerates through space, she is essentially trading her movement through time for movement through space. The faster she travels across the universe, the slower she moves through time relative to Bob. For Alice, the journey might feel like a few short years. She eats her meals, reads books, and sleeps just like normal. Her biological clock ticks at its usual rhythm. But when she lands back on Earth and opens the hatch, she steps into a nightmare. She finds that while she has aged only a few years, decades have passed for Bob. She returns to find her twin brother is now an old man, perhaps nearing the end of his life, while she's still in the prime of her youth. She hasn't traveled to the future in a magical sense. She has simply taken a shortcut through time that Bob couldn't take. This isn't just a clever math problem, it's a physical reality. Alice is effectively a ghost from the past haunting the future. The paradox lies in the symmetry. From Alice's perspective, wasn't it Earth that was moving away from her? Why is she the young one? The resolution lies in the acceleration. The force she felt when leaving and turning around broke the symmetry. But the existential scar remains. This paradox proves that there is no single timeline we all share. We are all drifting in our own private bubbles of time, and if we move too far or too fast, we risk losing everyone we love to the relentless current of a different clock. You might be tempted to dismiss the twin paradox as a purely theoretical puzzle, a strange quirk of mathematics that only matters to particle physicists or writers of science fiction. It is easy to think that here on the surface of Earth, time is solid and reliable. However, the frightening reality is that you rely on the malleability of time every single day just to navigate your world. Consider the global positioning system or GPS that lives in your smartphone and guides your car. This system depends on a constellation of 31 satellites orbiting the Earth at altitudes of 12,000 miles. These machines are moving at speeds of roughly 9,000 miles per hour, relative to the ground according to Einstein's special theory of relativity. This immense speed causes their onboard atomic clocks to tick more slowly than the clocks here on Earth, essentially keeping them younger than us by about 7 microseconds every day. But the story gets more complicated because there is a second thief of time at work, which is gravity. According to the general theory of relativity, gravity pulls on time just as it pulls on matter, because the satellites are far away from the massive bulk of the Earth. The grip of gravity on them is weaker than it is for us on the ground. This weaker gravity causes their clocks to run faster than ours by about 45 microseconds a day. So the engineers who built the system are faced with a conflict. The speed of the satellites slows time down, while their height speeds time up, when you combine these two opposing effects. The net result is that satellite clocks tick 38 microseconds faster than clocks on Earth every single day. 38 microseconds sounds like a vanishingly small amount of time, a ghost of a second that no human could ever perceive yet, for a system that relies on light signals traveling at 186,000 miles per second. This error is catastrophic. If the engineers did not program the satellites to artificially slow their clocks down to match ours, the entire system would drift by about 6 miles every single day. Within a few hours, your navigation would be useless, telling you that you are driving through a field when you are actually on a highway. Within a few days, the entire global infrastructure of transport and logistics would collapse, leading to chaos. This is not a theory. It is an engineering reality that keeps planes in the sky and ships on the ocean. It serves as a daily reminder that there is no such thing as a universal. Now the time you see on your phone screen is a manufactured lie, a correction applied to hide the terrifying truth that time flows differently for everyone and everything, depending on where they are and how fast they are moving. Speed is not the only force that can warp the flow of time. Gravity plays an even more sinister role, essentially acting as a heavy blanket that suffocates the ticking of the clock. Imagine gravity not just as a force that pulls you down toward the floor, but as a curvature in the very fabric of reality. The closer you are to a massive object like our planet, the deeper you are in the gravity well and the slower time moves. This leads to a bizarre and unsettling realization that time actually passes at different rates for different parts of your own body because your feet are closer to the center of the Earth than your head. They are technically aging slightly slower than your brain. Over the course of a human lifetime, this difference is infinitesimal, barely a fraction of a nanosecond, but it proves that you are not a single temporal entity, but a collection of parts moving through time at slightly different speeds. This phenomenon was proven beyond a shadow of a doubt in 1971 by physicists Joseph Hafele and Richard Keating. In a famous experiment, they took 4 highly precise cesium atomic clocks and flew them around the world on commercial jetliners twice, once heading east and once heading west when they landed, and compared the traveling clocks to the stationary ones at the United States Naval Observatory. The results matched Einstein's predictions perfectly. The clocks that had experienced different speeds and different gravitational potentials had recorded different amounts of time passed. The travelers had effectively time traveled into the future by a few billionths of a second compared to those who stayed behind. While the effect on Earth is small, imagine what happens in the extreme environments of the universe if you were to stand near the event horizon of a supermassive black hole, where gravity is millions of times stronger than on Earth. This dilation becomes extreme. A few hours spent in that crushing gravity could equate to centuries passing for the rest of the universe. Civilizations would rise and fall, stars would burn out and die, all while you ate a single lunch. This implies that time is viscous, like a thick syrup that flows slower. The closer you get to the source of gravity, it suggests that the center of the Earth is effectively younger than the surface, and that the core of our galaxy is lagging behind the spiral arms. We are not marching into the future in a straight line. We are wading through a turbulent ocean of time where deep currents can hold us back while the surface rushes forward. If time can stretch and squeeze like rubber, depending on gravity and speed, it raises a disturbing question. Can it also loop back on itself? Einstein's theory of general relativity allows for mathematical solutions known as closed time-like curves. These are essentially paths through space and time that curve so severely that they return to their own starting point in the past. If such a path exists, it opens the door to the most famous and logical nightmare in all of physics. The grandfather paradox let us conduct a thought experiment to see why this idea keeps scientists awake at night. Imagine that in the future you discover a wormhole, a tunnel through space-time that connects today with 60 years ago. Driven by curiosity or perhaps madness, you step through the wormhole and find yourself in the past, specifically at a time before your father was conceived. You locate your grandfather, who is still a young man, and for the sake of the argument, you decide to kill him. You raise a weapon and pull the trigger, eliminating him from history. Instantly, the consequences of this act ripple forward. If your grandfather dies young, he never meets your grandmother. Your father is never born, and consequently, you are never born. But here is where logic collapses. If you were never born, you could not have built a time machine or found a wormhole. You could not have traveled back to the past, and you certainly could not have pulled the trigger to kill him. Therefore, your grandfather lives, which means your father is born, which means you were born and you do go back to kill him. This creates an infinite oscillating loop of causality where you both exist and do not exist. At the same time, it is a logical short circuit in the machinery of reality, unlike the twin paradox, which is physically real but intuitive strange. This paradox suggests a fundamental breakdown in the architecture of the universe itself. It implies that the past and the future are not safe from each other, essentially destroying the concept of cause and effect. If an effect can eliminate its own cause, then the foundation of logic crumbles. Scientific laws are supposed to be consistent and predictive, but time travel introduces a chaotic element that makes prediction impossible, proving that either time travel is strictly forbidden by some unknown law or our understanding of logic is deeply flawed. Physicists have wrestled with the grandfather paradox for decades, trying to find a way to save the universe from this logical suicide. And they have come up with 2 main solutions, both of which are deeply unsettling in their own way. The first solution comes from Russian physicist Igor Novikov and is known as the Novikov self, consistency principle. This theory suggests that the universe behaves like a self-correcting organism that effectively protects its own history. According to this view, if you traveled back in time and tried to kill your grandfather, the laws of physics would conspire to stop you. The gun would jam at the crucial moment. You would slip on a banana peel and miss your shot, or perhaps you would only wound him, and that wound would be the very reason he meets your grandmother in the hospital. This solution saves logic, but it comes at a terrifying price. The loss of free will, it implies that if you travel to the past, you are merely an actor. Reciting lines in a play that has already been written, you have no agency to change anything. No matter how hard you try, the timeline is rigid, and your actions are predetermined by the future that you came from. You are a prisoner of causality forced to complete the loop, exactly as it happened before, forcing us to question if we have any control over our lives, even now. The second solution is perhaps even more dizzying. The many worlds interpretation of quantum mechanics suggests that reality is not a single line, but a constantly branching tree. According to this view, when you travel back and kill your grandfather, you do not erase your own history. Instead, you create a brand new diverging timeline. You have effectively stepped into a parallel universe where you never existed. But your original timeline where your grandfather lived and you were born remains intact and inaccessible. You can never return to the home you left because it lies on a different branch of reality. In this scenario, you become a temporal orphan, stranded in a world that is not your own, proving that while you might change the future, it is never your own future that you are changing. Just when you think the implications of time loops cannot get any stranger, we encounter the bootstrap paradox, also known as the ontological paradox, which challenges the very origin of information and objects. Imagine a scenario where you are a great admirer of the playwright William Shakespeare. You build a time machine and travel back to Elizabethan England, intending to meet your idol and perhaps get an autograph. However, when you arrive, you find that Shakespeare is just a bumbling actor with no talent for writing, terrified that the world will lose his masterpieces. You reach into your bag and pull out a complete book of his plays that you brought from the future. You hand the book to him and he proceeds to copy the plays and publish them under his own name. They become famous, history is preserved, and you return to the future satisfied. But wait a minute. Let us trace the origin of the plays. Shakespeare did not write them. He copied them from the book you gave him, but you did not write them either. You bought the book in the future because Shakespeare had written them. So, who is the author? The information contained in the plays seems to have no origin whatsoever. It exists in a closed loop without ever having been created by a human mind. This paradox applies to objects as well. Imagine you take a pocket watch back in time and give it to your grandfather. He keeps it all his life and eventually passes it down to your father, who passes it down to you. Then you take that same watch and travel back in time to give it to your grandfather. In this scenario, the watch has no clockmaker. It exists eternally in the loop, perhaps accumulating scratches and dust but never having been forged from raw materials. This concept violates our deepest understanding of cause and effect. Usually a cause leads to an effect, and every object has a source, but here the object is its own cause. Scientists call this a causal loop or a bootstrap paradox, named after the impossible act of pulling yourself up by your own bootstraps. It suggests that the universe might contain information that essentially came from nowhere, effectively making time a creator that requires no energy and no genius, just a twisted loop of geometry. This idea is logically valid in general relativity, though logically disturbing, implying that the universe is filled with ghosts of things that never truly began. The existence of objects without a creator or information without an author sounds like magic, but in the framework of general relativity, it is simply a matter of geometry. Imagine the universe not as a sequence of events happening one after another, but as a landscape of space-time. Usually we move through this landscape in a straight line from the valley of the past to the mountain of the future. However, if the geometry is twisted enough, gravity can bend that path into a circle, essentially creating a roundabout in time. In this circular path, an event is its own cause and its own effect, fundamentally challenging our definition of reality. Physicists call these uncaused causes, and they represent a profound break from the comfortable logic of our daily lives. In our world, we believe that everything must come from something. A chicken comes from an egg, A thought comes from a brain, a machine comes from a blueprint. But the bootstrap paradox suggests that the universe might allow for things to simply be there, self-sustaining and eternal with no point of origin. This concept is known as the Jinn paradox, in some scientific circles named after the genie from Middle Eastern mythology, that appears out of nowhere without being born. It implies that the universe does not necessarily need a beginning or a big bang for every single element within it. Some parts of reality might just be loops floating in the void, disconnected from the linear chain of history. This leads to a terrifying realization about the nature of information. If a complex theory or a masterpiece of art can exist in a loop without ever being invented by a human mind, then what does it say about human creativity? Are we truly inventing things, or are we just discovering information that has always existed in the geometry of the universe? Perhaps we are not creators, but merely receivers tuning into these closed loops of causality, picking up signals from a future that created itself. This perspective strips humanity of its agency, reducing us to mere cogs in a machine that runs on circular logic, suggesting that the universe is far stranger and more alien than we could ever comprehend. While time loops are a theoretical possibility that requires extreme gravity, there is a much more immediate and disturbing consequence of Einstein's relativity that affects every single moment of your existence. It is called the relativity of simultaneity, and it destroys the very concept of now we intuitively feel that there is a universal present moment, a cosmic slice of time that is happening right now. For everyone across the universe, we imagine that while we are sitting here watching this video, something specific is happening on Mars, and something else is happening in the Andromeda galaxy at this exact same instant. But Einstein proved that this universal now is a complete illusion. To understand why, let us look at the Andromeda paradox proposed by mathematical physicist Roger Penrose. Imagine two people walking past each other on the street. One is walking toward the Andromeda galaxy, and the other is walking away from it at a normal walking pace, because they are moving in opposite directions. Their definitions of simultaneous events in the distant universe are slightly different due to the immense distance to Andromeda, which is 2.5 million light-years away. This tiny difference in walking speed tilts their slice of the present significantly. For the person walking toward the galaxy, there now might include an alien fleet launching an invasion for the person walking away. There now might include the fleet still planning the mission days or even weeks earlier. This means that there is no single objective truth about what is happening right now in the universe. Two people passing each other on the street effectively inhabit different versions of the present purely because of their motion relative to the stars. If your now is different from my now, then the present moment is not a global frontier moving forward. It is a subjective perspective unique to every observer. This shatters the idea that the past is gone and the future has not happened yet. If the alien invasion is in the past for one observer and in the future for another, then the invasion must simply exist suspended in space-time, waiting to be encountered. This leads us to the most rigid and claustrophobic map of reality known to science, the block universe. If there is no universal now, and if different observers can disagree on whether an event has happened or is yet to happen, then we are forced to accept a radical conclusion. All moments in time must exist simultaneously. Physicist Brian Greene and others often use the analogy of a giant loaf of bread to explain this terrifying concept. Imagine the entire universe and its entire history as a long rectangular loaf. Every slice of that bread represents a moment in time for a specific observer. One slice might contain the extinction of the dinosaurs. Another slice contains the building of the pyramids, and a slice much further down contains your birth and eventually your death. For us trapped inside the loaf, moving slice by slice, it feels like time is flowing. We remember the bread behind us and we cannot see the bread ahead of us, but from the perspective of physics, the whole loaf simply sits there statically. The past did not vanish after it happened, and the future is not waiting to be created. It is already there, baked into the block, just as real and solid as the present moment. This view is called eternalism. and it suggests that time does not flow at all. Instead, the universe is a four-dimensional crystal of frozen events where every scream, every laugh, and every collision of stars is preserved forever, like an insect trapped in amber. This visualization transforms our understanding of existence from a dynamic journey into a static prison. It means that your death is not a distant possibility that you might avoid or delay. It is a physical location in the block universe that already exists. Just as surely as the chair you are sitting on exists, implies that you are not living your life. You are merely experiencing it moment by moment, like a needle reading the grooves of a record that was pressed billions of years ago. The music feels like it is moving, but the entire song is already written on the vinyl, from the first note to the final silence. Nothing changes in the block universe, nothing evolves. The entire history of the cosmos is a single unchangeable object, floating in a timeless void. The implications of the block universe theory are psychologically devastating, because they launch a direct attack on our most cherished belief, the belief in free will. We wake up every morning feeling that the day is a blank page waiting to be written. We believe that we have the power to make choices to turn left instead of right to speak, or to stay silent to change our destiny. But if the block universe model is correct, this feeling of freedom is nothing more than a persistent neurobiological illusion produced by our brains to keep us sane if the future is already physically real. Sitting there in the space-time block, then your choices are not truly choices, they are simply the next steps in a pre-calculated path that you are compelled to walk. When you decide to lift your arm, that decision creates a neural pattern in your brain. But that pattern and the lifting of the arm are events that occupy specific coordinates in the block. They have always been there long before you were born. In this view, you are not the writer of your story. You are the main character reading a script that was finished at the moment of the Big Bang. You might feel the suspense of not knowing what happens next, but the universe knows. The film implies that the future is just as fixed and unalterable as the past. We do not try to change the past because we know it is impossible. Yet, we exhaust ourselves trying to shape the future, not realizing that, in the eyes of relativity, the distinction between yesterday and tomorrow is merely a trick of perspective. Einstein himself found comfort in this idea when his close friend Michel Besso died. Einstein wrote a letter to Besso's family saying, "Now he has departed from this strange world a little ahead of me. That means nothing. People like us who believe in physics know that the distinction between past, present, and future is only a stubbornly persistent illusion." He was embracing the horror of the block universe to accept death. If all moments exist forever, then his friend was not gone. He was simply in a different part of the block, safe and eternal. But for the rest of us, the idea that we are puppets on the strings of geometry without true agency is a source of profound existential dread. If the universe is truly a frozen block of ice where every moment exists simultaneously, why do we feel such a powerful sensation of flow? Why do we remember the past but not the future? And why can we break an egg but never unbreak it? This deep contradiction brings us to the concept of the arrow of time and the iron law that governs its entropy. While the laws of relativity and quantum mechanics work perfectly well in reverse, a planet orbiting a star backward is still physically valid. There is one rule that refuses to be reversible: the second law of thermodynamics. This law states that in any closed system, the amount of disorder or entropy always tends to increase over time. Think of a cup of coffee sitting on the edge of a table. If you knock it over, the cup shatters and the brown liquid splashes across the white floor. This is a transition from order, a neat cup and separate liquid, to disorder, a chaotic mess of shards and stain. You will never see the puddle spontaneously jump back into the cup and the shards seal themselves back together. Not because it is physically impossible, but because it is statistically incredibly unlikely. There are billions of ways for the atoms of the cup to be arranged in a messy pile, but only one specific arrangement where they form a perfect intact cup. The arrow of time is essentially a measure of probability driving the universe from unlikely states of order to likely states of chaos. This relentless march toward disorder is the only thing that gives time a direction. It is the reason your body ages as your cells accumulate errors and damage. It is the reason stars burn out as they convert concentrated fuel into scattered heat and light. Entropy is the tax we pay for the passage of time without entropy. There would be no difference between the past and the future, and the movie of your life would look exactly the same played forward or backward. This leads to a tragic realization that the sensation of living the very flow of time that we cherish is actually the sensation of the universe dying moment by moment. We are surfing on a wave of decay, and every second that ticks by is a measurement of something valuable being lost forever into the chaos. The realization that time is driven by the decay of order into chaos is not just a cold physical fact, it is a human tragedy that claimed the life of one of the greatest minds in history. Ludwig Boltzmann, living in the late 19th century. Boltzmann was a visionary who championed the existence of atoms at a time when most scientists considered them to be convenient fictions. He realized that if matter is made of tiny particles bouncing around, then the behavior of the entire universe, including time itself, is a game of statistics. He argued that low entropy states like a perfectly formed egg or a living human body are incredibly rare, while high entropy states like a broken egg or a corpse are overwhelmingly common. Therefore, the arrow of time is simply the universe moving from the unlikely to the likely. Boltzmann saw that the past is different from the future only because there are more ways for the universe to be messy than to be tidy. Unfortunately, his ideas were met with vicious ridicule and hostility from the scientific establishment of his day, who believed that the laws of nature should be absolute and not merely probable. Tormented by the rejection of his life's work and struggling with depression, Boltzmann hanged himself in 1906 while on vacation with his family, tragically, just a few years before experiments definitively proved the existence of atoms, vindicating his genius. Today, his tombstone in Vienna bears a simple inscription: S equals K log W, the formula for entropy. This equation is the mathematical definition of our mortality. It explains why you cannot unburn a match or unremember a memory. It dictates that every breath you take increases the disorder of the universe, pushing it one step closer to a final state of equilibrium where nothing interesting can ever happen again. Boltzmann showed us that the flow of time we perceive is essentially the universe dissolving. It is not a creative force marching toward a destiny. It is a destructive force sliding toward oblivion, and we are merely temporary patterns of order, riding the landslide of decay, forcing us to accept that our existence is a statistical anomaly in a cosmos that prefers dust and chaos. While entropy dictates the direction of time, the speed of light dictates its boundaries, creating a claustrophobic prison known as the light cone. According to relativity, nothing can travel faster than light, which means there is a strict limit on what can affect us and what we can affect. Imagine you are floating in the emptiness of space at any given moment. You are at the center of a bubble defined by how far light has traveled since the beginning of time. Everything inside this past light cone is part of your history. Events that could have influenced you, everything inside your future. Light cone is your destiny. Places you could theoretically reach or send a signal to. But here is the terrifying part. The vast majority of the universe lies outside these cones in a region physicists call the absolute elsewhere. If the sun were to vanish right now, we would not know it for 8 minutes. Because the event is outside our light cone for those 8 minutes, the sun is gone, but for us, it is still shining. Gravity still holds Earth in orbit, and photosynthesis continues. We are living in a ghost world, disconnected from the true reality of the star. This means that for any observer, huge sections of the universe are causally disconnected, utterly beyond reach, no matter how much time passes. There are galaxies moving away from us faster than light, due to the expansion of space, which means they have crossed the cosmic horizon and exited our future light cone forever. We are effectively isolated in a shrinking bubble of causality as the universe expands. More and more of it slips into the absolute elsewhere, becoming physically irrelevant to us. It is a profound cosmic loneliness, suggesting that we can never truly know the state of the universe. Right now, we are always looking at an ancient history, perceiving stars that might have died millions of years ago and sending signals to galaxies that will never receive them. We are trapped in a cell of light, and the walls are closing in, reminding us that our influence on reality is strictly confined by the speed limit of the cosmos. The speed of light is the ultimate speed limit of the universe, but what if something could break it? This question leads us to the hypothetical and mind-bending realm of Tachyons particles that theoretically travel faster than light, while they have never been observed, and likely do not exist. The mathematics of relativity does not strictly forbid them, it just demands that they have an imaginary mass. Whatever that might mean physically, if tachyons were real, they would shatter our understanding of time, because in the equations of relativity, traveling faster than light is equivalent to traveling backward in time. Imagine you had a device called a tachyon anti-telephone, capable of sending signals using these superluminal particles. You could technically send a message to your past self, warning of a stock market crash or a car accident. You would press the send button at noon, and the message would arrive at your computer at 11 in the morning. This creates an impossible loop of causality. Suppose you arrange a mechanism where a bomb is set to explode at noon, unless it receives a tachyon signal from the future. At 1 o'clock, you see the explosion did not happen, so you send the signal back to stop it. But if the signal stops the explosion, then the explosion never happened, so you never had a reason to send the signal. This paradox proves that if faster than light travel is possible, then the entire structure of cause and effect collapses. The universe could not function if effects preceded their causes. It would be a chaotic soup of logical contradictions where history could be rewritten constantly. Physicists generally believe that tachyons are an artifact of the math rather than a feature of reality, a warning sign that says do not cross this line. However, the very fact that our best theory of time allows for such monsters in the equations suggests that our understanding is incomplete, or that the universe is far more fragile than we dare to admit. Balancing on the razor's edge of paradox, we have journeyed through the landscape of classical relativity and thermodynamics, and the view is already terrifying. We have seen that time is not a universal constant, but a malleable dimension that stretches with speed and bends with gravity. We have learned that our intuitive sense of now is an illusion that the past and future might exist simultaneously in a frozen block universe, and that the only reason we perceive a flow is because we are sliding down a slope of increasing entropy toward heat. Death, we have even stared into the logical abyss of time loops and causal violations, where history can eat its own tail, yet as disturbing as these ideas are, they all belong to the macroscopic world, the world of stars clocks and human observers. But reality has a basement, a subatomic realm where the rules of logic do not just bend, they shatter completely as we descend into the quantum world. The smooth fabric of space-time dissolves into a foaming sea of probability. Here, particles can be in two places at once. Events can happen without a clear order, and the very act of looking at a clock might stop it from ticking. Relativity told us that time is a dimension like space, but quantum mechanics whispers something far worse, that time might not exist at all, or that it is a secondary effect generated by the entanglement of matter like heat rising from a fire. Prepare yourself, because we are about to leave the world of cause and effect behind and enter the broken reality of the quantum paradoxes, where the simple act of observation is an act of violence against time itself. In our daily life, we assume that the world continues to change whether we are watching it or not. A pot of water will eventually boil even if you stare at it intently. But in the quantum world, this common wisdom is turned on its head, leading to a phenomenon known as the quantum Zeno effect, named after the ancient Greek philosopher Zeno, who argued that motion is impossible. This effect suggests that a constantly observed quantum system literally cannot change. State. Simply put, a watched quantum pot never boils. This is not a metaphor. It is a proven physical fact demonstrated in the laboratories with atoms and lasers. To understand this, we must realize that quantum systems do not have a fixed reality until they are measured. They exist as a wave function, a cloud of probabilities evolving over time, an unstable atom. For instance, has a probability of decaying that grows as time passes. However, when you measure the atom, you force the wave function to collapse into a single definite state, either decayed or not decayed. If you measure it early enough, the probability of it being decayed is near zero, so it will almost certainly be found in its original undecayed state. The paradox arises when you measure it repeatedly and rapidly, essentially checking on it thousands of times a second. Each measurement resets the wave function back to zero, stopping the evolution of the probability. Effectively, the act of observation freezes the atom in time, preventing it from ever changing or decaying. It is as if your gaze is a force of nature that arrests the flow of time for that object. This implies a deeply disturbing connection between consciousness, or at least measurement, and the passage of time. It suggests that time only flows when the universe is not being watched closely. If we could observe every single particle in the universe continuously, would time stop altogether? Are we the ones pushing the play button on reality simply by blinking and looking away, or is our observation the cage that traps the universe in a specific state, preventing it from evolving into something else? The quantum Zeno effect is not just a philosophical curiosity, it is a documented phenomenon that challenges our assumption that the world exists objectively, whether we are looking at it or not. In 1989, physicists David Wineland and Wayne Itano conducted a landmark experiment at the National Institute of Standards and Technology. They trapped beryllium ions in magnetic fields and subjected them to radio frequency pulses that should have caused the ions to gradually flip their energy states from a ground state to an excited state, essentially moving them through time from one condition to another. Under normal circumstances, this transition happens smoothly, like a dimmer switch being turned up. But when the physicists measured the state of the ions at very short intervals, effectively asking, "Are you flipped?" yet thousands of times a second, the transition stopped completely. The ions remained frozen in their initial state, held in place by the sheer frequency of the observation. This experiment implies that the smooth flow of time we perceive might actually be a series of discrete snapshots stitched together by our consciousness. Imagine watching a movie on your computer. If you press the pause button rapidly enough, the image never changes, the actors never move, and the story never advances in the quantum world. The act of measurement is that pause button. It forces the universe to decide on a specific reality right now rather than evolving into a new one. This leads to a dizzying conclusion about the nature of existence itself. Does a tree falling in a forest make a sound if no one is there to hear it? Quantum mechanics suggests a more radical answer if no one is there to measure it. The tree might not even fall in a definite sense. It remains in a superposition of falling and standing, evolving through time only until an observer interacts with it. This places the observer at the center of the temporal universe, suggesting that we are not passive passengers watching the scenery go by, but active participants who are constantly collapsing the wave function of the cosmos, creating the history of the universe. Simply by opening our eyes and bearing witness without us, the universe might just be a blur of timeless probabilities waiting for a definition. If the idea that your gaze can freeze time is not disturbing enough, consider the possibility that your choices right now can rewrite the past. This concept, known as retrocausality, is demonstrated by the famous delayed choice experiment, proposed by John Archibald Wheeler. Imagine a photon of light traveling from a distant star 1 billion light years away on its journey to Earth. It encounters a galaxy that acts as a gravitational lens, warping space, and offering the photon two possible paths to reach its path A to the left, or path B to the right, according to quantum mechanics, until the photon is measured. It does not take one path or the other, it travels both, simultaneously acting as a wave of probability. Here is where the nightmare begins. Eventually that photon reaches Earth and enters a telescope, where you, the observer, have a choice. You can choose to measure which path the photon took, effectively asking did you go left or right, or you can choose to measure the interference pattern, effectively asking did you behave like a wave logic dictates that the photon must have decided how to travel 1 billion years ago, long before you were born. But experiments show that the nature of the photon, whether it was a particle on one path or a wave on both, is determined by the measurement you make today. If you choose to look for a path, the photon effectively says, I took path A 1 billion years ago. If you choose to look for a wave, the photon says, I took both paths 1 billion years ago. This implies that your decision in the present moment reaches back across the eons and forces the photon to assume a specific history that it did not have until now. It suggests that the past is not written in stone, but is a cloud of possibilities that only crystallizes when the future interacts with it. This obliterates the linear cause and effect relationship. We rely on proving that the arrow of time is not a one-way street at the quantum level. The future has a hand on the steering wheel of the past, shaping history in its own image. We have seen how time bends, breaks and loops, but nowhere does it face a more catastrophic failure than at the edge of a black hole. For decades, physicists believed that black holes were simply eternal prisons where matter and light entered and never returned. But in 1974, Stephen Hawking dropped a bombshell on the scientific community. He used quantum field theory to show that black holes are not truly black. They emit a faint glow of radiation, now known as Hawking radiation. This radiation carries energy away from the black hole, causing it to slowly shrink and eventually, after an unimaginably long time, vanish completely from the universe, leaving nothing behind, not even a hole. This discovery led to the most dangerous paradox in modern physics, the black hole information paradox. Imagine you take a book containing vital information, say the only copy of your diary, and you throw it into a fireplace. The book burns to ash, and the information seems lost. But according to the laws of quantum mechanics, the information is technically preserved in the smoke, the ash and the photons of heat released by the fire. If you had a supercomputer capable of tracking every single particle, you could theoretically reconstruct the book. Fundamentally, physics says that information is immortal. It can be scrambled, but never destroyed. This principle is called unitarity. However, when a book falls into a black hole, it is crushed into the singularity. Later, the black hole evaporates via Hawking radiation. But here is the problem. Hawking's calculations showed that this radiation is completely random, thermal noise. It contains no information about what fell inside. If the black hole disappears completely and the radiation carries no record of the book, then the information has been erased from existence utterly and irreversibly. This violation of unitarity suggests that the universe has a fundamental leak, a drain where history can be deleted if information can be destroyed. Then the past is not real, and the ability to predict the future collapses. The very foundation of science relies on the idea that the present state of the world depends on the past, but black holes threaten to sever that link, making time a bridge that leads nowhere. The realization that black holes might be cosmic erasers sparked a bitter intellectual war that lasted for decades, pitting Stephen Hawking against Leonard Susskind and Gerard 't Hooft. The stakes were nothing less than the validity of physics itself on one side. Was Hawking arguing that general relativity essentially proves that the singularity destroys information, meaning quantum mechanics is wrong or incomplete on the other side? Was Susskind arguing that quantum mechanics is supreme and information must be preserved, meaning our understanding of black holes is flawed? If Hawking was right, it meant that our memories, our history, and the physical laws we rely on are not permanent. They can be voided by gravity, essentially creating a universe with amnesia, where the past can be amputated. Implies that at any moment, a piece of reality could simply cease to have ever existed, destroying the logical consistency of time. Susskind realized that if information loss were allowed, energy conservation and predictability would also fail, turning the universe into a chaotic nightmare where anything could happen without a cause. This conflict forced physicists to propose radical and almost hallucinatory solutions to save reality. One such idea is the concept of black hole complementarity, which suggests that an astronaut falling into a black hole experiences two different realities simultaneously. From his perspective, he crosses the horizon and floats toward the center unharmed, carrying his information with him, but from the perspective of a distant observer, the astronaut never crosses the horizon. Instead, he is burned up and flattened against the surface, essentially existing in two places at once, dying and living depending on who is asking the question. This desperate attempt to save the laws of physics paved the way for the strangest theory of all, the idea that our three-dimensional world is a lie. To resolve the war between gravity and quantum mechanics, Leonard Susskind and Gerard 't Hooft proposed a solution so bizarre that it sounds like the plot of a simulation theory movie. They introduced the holographic principle. Imagine a can of soup. Usually we think that the information describing the soup, the vegetables, the broth, the noodles, is contained inside the volume of the can. However, Susskind argued that in the case of a black hole, all the information about the objects that fall inside is not lost in the center, but is instead plastered onto the surface of the event horizon, like a sticker on the outside of the can. This implies that the event horizon acts as a two-dimensional storage device, a hard drive shell that encodes everything inside it when the black hole evaporates. The Hawking radiation picks up this data from the surface and carries it back into the universe, saving the information and preserving the past, but the implications of this extend far beyond black holes. If the physics of the most extreme objects in the universe works this way, then mathematically, the entire universe must work this way. The holographic principle suggests that our entire three-dimensional reality, including you, me, the stars, and the depth of space we perceive, is effectively a projection of information stored on a distant two-dimensional surface at the edge of the cosmos, just as a credit card hologram creates the illusion of 3D depth from a flat plastic strip. Our universe might be a hologram generated from a flat boundary. This means that volume is an illusion and that the third dimension is not fundamental. Essentially, we are flat creatures, mistakenly believing we have depth living in a projection that hides the true nature of space-time. If this is true, then time as a dimension of change within a 3D world is also a projection, a secondary variable that emerges from the interactions of the real flat data, implying that we are literally living in a cosmic simulation encoded on the walls of reality. If the idea that our three-dimensional reality is merely a projection from a two-dimensional surface sounds like the ravings of a madman, you should know that it is actually the central pillar of modern theoretical physics, specifically a concept known as the anti-de Sitter, conformal field theory correspondence, or ADA-CFT, discovered by the Argentine physicist Juan Maldacena in 1997. This discovery sent shockwaves through the scientific community that are still felt today, because it provided the first mathematical proof that a universe with gravity like ours can be exactly equivalent to a universe without gravity that exists. Only on the boundary, imagining this requires stretching your mind to its absolute limit. Consider a snow globe inside the glass sphere. There is a rich three-dimensional world with snowflakes falling a tiny house, and perhaps a snowman occupying volume and interacting with gravity. Now imagine that the glass shell of the snow globe is covered in a complex pattern of pixels like a super high resolution screen. Maldacena showed that every single event that happens inside the globe, the falling of a snowflake, the structure of the house can be perfectly described by equations governing the pixels on the surface, without ever referencing the inside of the sphere at all. In this analogy, we are the snowmen living inside the globe, believing that we have depth that we can move forward and backward, and that space is a vast arena around us, but in reality we are simply shadows generated by the interactions of quantum particles on the distant glass shell. Essentially, we are a movie projected onto a screen, but we are convinced that we are the actors inside the scene. The mathematics is so precise that you can translate a problem of infinite complexity inside the volume into a simpler problem on the surface. solve it there, and then translate the answer back, and it works perfectly. This suggests that the third dimension, essentially height or depth, is not a fundamental feature of the universe, but an emergent property, a useful illusion that our brains construct to make sense of the data streaming from the boundary. Just as a 3D video game is ultimately just a stream of zeros and ones on a flat microchip, our universe might be a grand simulation running on the edge of nothingness. The implications of this for time are even more staggering if space is an emergent hologram. Then time as we perceive it, the fourth dimension, must also be a holographic projection in the boundary theory on the surface time exists as a rigid parameter. But inside the bulk, where we live, time becomes flexible curving and warping according to general relativity. This means that the flow of time you experience right now, the feeling of seconds ticking by, is likely a secondary effect, a mirage created by the entanglement of quantum fields on the edge of the cosmos. It implies that, at the most fundamental level, there is no space and there is no time. There is only information, purely abstract data interacting with itself, essentially making the universe a giant quantum computer, and as the software running inside it, unaware that our physical bodies are just avatars for a code written on the horizon of eternity. While the holographic principle suggests that the structure of space-time is an illusion, the equations of general relativity offer another even stranger possibility regarding the direction of time. We are all familiar with black holes, those cosmic monsters from which nothing, not even light, can escape. They are the ultimate trap, a one-way door that leads only to destruction. However, the equations that Einstein wrote down to describe gravity are time-symmetric, meaning they work exactly the same way, whether time flows forward or backward. If you film a planet orbiting a star and play the movie in reverse, the physics still makes perfect sense. Gravity works the same, orbits work the same. So physicists asked a simple but provocative question: if we take the mathematical movie of a black hole forming and swallowing matter, and we play it backward, what do we see? The answer is a white hole, an object that is the exact opposite of a black hole in every way. While a black hole is a region of space you can enter, but never leave, a white hole is a region you can leave but never enter it. Creates a horizon that allows matter and light to rush out at incredible speeds, but forbids anything from the outside universe from ever crossing in it, is a cosmic fountain spewing out energy and mass. Likely the remains of whatever fell into a black hole in a distant past or a different universe. Imagine an object with gravity so intense that it repels time itself, forcing the arrow of causality to flip locally around a white hole. The future flows outward away from the singularity, making it impossible to travel inward, just as it is impossible for us to travel backward in time to last Tuesday. For decades, white holes were considered nothing more than a mathematical curiosity, a quirk of the algebra, with no basis in reality. Scientists argued that they would be impossibly unstable, that the moment a single speck of dust tried to enter one, the collision with the outgoing stream of matter would cause the entire structure to collapse into a black hole. However, the discovery of dark energy and the accelerating expansion of the universe has rekindled interest in these impossible objects. Some cosmologists, notably Lee Smolin, have suggested that the Big Bang itself might have been a white hole, a sudden explosion of time-space and matter from a singularity essentially creating our universe from the output of a black hole in a parent universe. This theory presents a breathtaking cyclical vision of reality where time does not just end in a crunch or fade into a whimper, but flows through a network of cosmic plumbing, connecting different eras and different realities, effectively making the death of one timeline the birth of another. The connection between black holes and white holes was largely poetic until a physicist began applying the rules of quantum mechanics to the structure of space-time itself, leading to a theory known as loop quantum gravity, while string theory tries to unify physics by adding extra dimensions. Loop quantum gravity takes a different approach, suggesting that space itself is made of discrete chunks, tiny indivisible grains of geometry, just as a beach is made of grains of sand. According to this view, you cannot divide space infinitely. There is a smallest possible unit of volume, a quantum of space which is about a billion times smaller than a proton. This granular structure changes everything, especially when it comes to the ultimate catastrophe of the singularity. In the classical view, when a star collapses into a black hole, it is crushed down to a point of zero size and infinite density, essentially breaking the laws of physics. But if space is granular, the star cannot be crushed to zero once it is squeezed down to the size of the smallest possible quantum of space. It cannot get any smaller. The grains of space effectively push back, creating a quantum repulsive force that is stronger than gravity. This is similar to how electrons resist being squeezed into the same orbit, preventing atoms from collapsing. When the collapsing matter hits this bottom floor of reality, it does not stop or vanish. Instead, it bounces. This event is called a quantum bounce. The implosion of the black hole suddenly reverses and turns into an explosion, effectively transforming the black hole into a white hole. But here is where the elasticity of time plays a cruel trick, due to the extreme time dilation near the center of the hole. This bounce happens almost instantly from the perspective of the star, taking perhaps a few milliseconds, but for us watching from the outside, billions of years pass because gravity slows time down so dramatically the star is bouncing right now in its own time frame. But we perceive that bounce in slow motion as a black hole lasting for eons. This theory suggests that every black hole in the universe is essentially a pregnant baby universe, in the process of being born, held in a state of suspended animation by the warping of time eventually as the black hole evaporates, and its gravity weakens, the time dilation will fade, and the white hole will erupt into our reality, revealing the matter that was swallowed billions of years ago, effectively proving that time is not a destroyer, but a preserver keeping the past safe in a quantum vault until it is ready to be released into the future. As we dig deeper into the foundations of quantum gravity, looking for the engine that drives time, we hit what might be the most disturbing obstacle in the history of physics, known as the problem of time in the late 1960s. Physicists John Archibald Wheeler and Bryce DeWitt set out to combine quantum mechanics with general relativity into a single master equation that would describe the entire universe. Usually in physics, equations describe how a system changes over time, for example, how a ball moves through the air, or how a population grows second by second. The variable t for time is always the backbone of the math. Simply put, things evolve, but when Wheeler and DeWitt combined the math of Einstein with the math of Schrödinger, they found something shocking. The variable t simply cancelled out. The resulting formula, known as the Wheeler-DeWitt equation, looks deceptively simple. H times psi equals 0, but its implications are shattering. It describes a universe that does not evolve. The quantum state of the cosmos is static, frozen in a single eternal configuration. According to this equation, the universe does not happen. It simply is. There is no past. There is no future, and there is no passage of time at the fundamental level of reality. This result was so confusing that it was initially thought to be a mistake. But decades of scrutiny have only reinforced it, suggesting that time is not a part of the hardware of the universe, but merely a user interface generated by our specific perspective. Imagine taking a movie reel and cutting it up into thousands of individual frames, then tossing them into a chaotic pile on the floor. The pile itself does not change. It is just a collection of static images. The Wheeler-DeWitt equation describes the pile, the collection of all possible states of the universe existing simultaneously, without any inherent order. The sensation of time passing is an illusion that arises because we, deeply embedded within one of the frames, construct a logical relationship with other frames that look similar, creating a narrative of cause and effect, much like flipping through the pages of a book, creates the illusion of motion. This view, known as the frozen formalism, implies that we are not moving through time. Rather, we are stationary consciousnesses inhabiting a specific slice of the pile, perceiving a flow that exists only in our minds, while the universe itself stands perfectly still, timeless and complete. The frozen nature of the Wheeler DeWitt equation highlights a deep and dangerous fracture in the bedrock of modern science, a conflict that has been called the catastrophe of the vacuum or the crisis of physics. Fundamental physics rests on two pillars: general relativity, which governs the macro world of stars and gravity, and quantum mechanics, which governs the micro world of atoms and particles separately. They are incredibly successful, capable of predicting everything from the orbit of Mercury to the behavior of a microchip to absolute precision, but they have one fatal disagreement, and that disagreement is about the nature of time itself. In general relativity, time is flexible. It is a dynamic participant in the drama of the universe. It stretches, it shrinks, it curves, and it interacts with matter. It is like a soft clay that is molded by the actors on the stage, but in quantum mechanics, time is rigid and absolute. It is the background stage upon which the actors perform a steady metronome that ticks away, unaffected by what the particles are doing in quantum equations. Time is treated just like it was in the days of Newton, a universal parameter that marches forward 1 second per second everywhere. And always, when physicists try to combine these two theories to describe the universe as a whole, or to understand extreme environments like the Big Bang or black holes, the math explodes into nonsense, usually yielding answers like infinity. This friction arises because quantum mechanics requires a fixed background time to calculate probabilities, while general relativity insists that no such background exists because gravity destroys it. This is not just a technicality, it is a sign that our understanding of reality is deeply broken. It suggests that one of these theories, or perhaps both, is fundamentally wrong about what time is. String theory attempts to solve this by adding extra spatial dimensions, essentially diluting the problem, while loop quantum gravity attempts to solve it by quantizing space itself. But until a unified theory of quantum gravity is found, we are left with a schizophrenic view of the universe where time is both a flexible fluid and a rigid ruler depending on how close you look, suggesting that time might not be a fundamental ingredient of the cosmos at all, but an emergent property that appears only when we zoom out, like the smoothness of water that hides the chaotic molecules beneath. If time does not exist fundamentally in the equations of the universe, then we are left with a massive problem, explaining our own daily experience. We see glasses break, we feel ourselves getting older, and we watch the sun rise and set. So how can a static, timeless universe give rise to such a convincing illusion of flow? The answer might lie in the strange phenomenon of quantum entanglement. In 1983, physicists Don Page and William Wouters proposed a radical mechanism suggesting that time is an emergent property, a side effect of quantum correlations rather than a fundamental ingredient of reality. Imagine the universe as a vast static collection of quantum particles entangled with one another in a state that does not evolve globally from the outside, looking in from the perspective of a hypothetical God who stands outside the universe. Nothing changes. The total energy is zero, and the quantum state is frozen forever, essentially a painting that is already finished. However, Page and Wouters showed that the view is very different from the inside. If you divide this static universe into two parts, let us call them the clock and the observer, a miraculous thing happens simply because the observer is entangled with the clock. The measurement of one part reveals a change in the other. This creates the perception of evolution relative to the observer. The clock appears to tick, and events appear to happen sequentially. Even though the system as a whole remains motionless, it is like walking through a dense fog where the landscape is stationary, but your movement creates the illusion of swirling mists and shifting shapes. Time in this view is a measure of our entanglement with the rest of the world. It is a relationship, not a dimension. This idea was confirmed experimentally in 2013 by a team at the Istituto Nazionale di Ricerca Meteorologica in Italy, who created a toy universe of entangled photons. They demonstrated that when viewed from the outside, the system was static and unchanging, but when observed from within, the system showed a clear evolution, over time confirming the Page-Wouters hypothesis. This leads to a profound realization that time is similar to heat. Heat is not a fundamental particle. You cannot find a heat atom under a microscope. Heat is simply the motion of many atoms hitting each other. It is an emergent property that only makes sense when you have a lot of particles interacting. Similarly, time might be the heat of quantum entanglement, a macroscopic illusion that arises from the microscopic connections binding the universe together, suggesting that if we could untangle ourselves from the cosmos, time would simply vanish, leaving us in an eternal frozen. Now we have explored how time might be an illusion, but there is a far more violent threat lurking in the equations of particle physics, a threat that could end time not by revealing it as fake, but by destroying the physical stage upon which it plays. This is the catastrophe of vacuum decay. Usually, when we think of a vacuum, we think of empty space, nothingness, but in modern physics, a vacuum is not empty. It is filled with quantum fields that dictate how particles behave and how the forces of nature operate. One of the most important of these is the Higgs field, which gives particles like electrons and quarks their mass effectively, allowing atoms to form and structure to exist. We assume that this field is in its most stable state, like a ball that has rolled down to the very bottom of a valley where it can rest forever. However, calculations involving the mass of the Higgs boson and the top quark suggest a terrifying possibility. The Higgs field might not be at the true bottom of the valley. Instead, it might be stuck in a small dip halfway up the hill, a state known as a false vacuum or a metastable state. Imagine you are camping in a valley, believing you are at sea level, but in reality, you are in a high mountain lake, held back by a thin, fragile dam of rock below. You lies the true vacuum, a state of much lower energy. If the dam breaks, the lake will drain catastrophically, rushing down to the true bottom, taking everything with it in cosmic terms. This means our universe is balancing on a razor edge. Stability is not guaranteed. It is merely a temporary pause in a process of cosmic settling that has not finished yet. If the Higgs field were to tunnel through the energy barrier and drop to the true vacuum state, it would release a colossal amount of potential energy. This transition would fundamentally rewrite the laws of physics, the constants of nature that we take for granted. The mass of the electron, the strength of electromagnetism would instantly change, resulting in a universe where chemistry as we know it is impossible. Atoms would not hold together, stars would not shine, and biological life would cease to be a possibility. This idea transforms the vacuum of space from a boring void into a ticking time bomb, essentially a loaded gun pointed at the head of reality waiting for a quantum fluctuation to pull the trigger. The horror of vacuum decay lies not just in the destruction of matter, but in the absolute stealth and speed of the event. If a quantum fluctuation were to trigger the collapse of the Higgs field somewhere in the universe, it would create a bubble of true vacuum. This bubble would not remain small, fueled by the release of potential energy. It would expand outward at the speed of light in all directions, creating a sphere of death that consumes galaxies, stars and planets, transforming them from organized matter into a chaotic soup of unknown physics. Because the wall of the bubble travels at the speed of light, it is physically impossible to see it coming. Light carries information, and the bubble wall is moving just as fast as the light that would warn you. This means there would be no warning signs, no ominous glow in the sky, no slow dimming of the stars. One moment you would be sitting there drinking your coffee, reading a book, or hugging a loved one, and in the very next nanosecond you would simply cease to exist. Your atoms would fall apart, your consciousness would evaporate, and the laws of physics that allowed you to live would be repealed instantly, effectively deleting you from the universe before your brain could even process the electrical signal of pain or fear. It is the ultimate sudden death, a cosmic sniper shot that could happen 1 billion years from now or 5 seconds from now as you listen to this sentence. Even more disturbing is the fact that once the bubble starts, it cannot be stopped. It will continue to expand forever. devouring the entire observable universe and converting it into a weird new state where life is impossible. Time as a measure of change and evolution for complex beings like us would end, abruptly replaced by the sterile, timeless physics of the true vacuum. This scenario, known as the Big Slurp, makes all our human concerns about the future seem laughably insignificant. We worry about climate change, about wars, about the death of the sun, but we are standing on a trapdoor that could open at any moment without reason or warning, proving that the stability of time itself is a gamble. We win every single second until we lose. If the physical destruction of the universe is not enough to keep you awake at night, let us turn to a paradox that attacks your mind and your memory directly. The problem of Boltzmann brains. This concept emerges from the intersection of eternity and entropy. As we discussed earlier, Ludwig Boltzmann realized that the universe tends toward disorder because there are simply more disordered states than ordered ones. However, in a universe that lasts forever, or is incredibly vast, extremely unlikely events eventually become certainties. Quantum mechanics allows for random fluctuations where particles spontaneously come together to form structures. Usually, these fluctuations are small, like a pair of particles popping into existence, but given infinite time, a fluctuation large enough to assemble a fully formed atom, a star, or even a human brain is mathematically inevitable. This leads to a disturbing statistical argument. It is incredibly difficult to create an entire universe like ours, with billions of galaxies and a 13 billion year history of evolution, that eventually produces intelligent observers like you. It requires a state of incredibly low entropy at the Big Bang, which is statistically virtually impossible. It is far, far easier, and much more probable, for a random quantum fluctuation to simply arrange atoms into the shape of a single brain, complete with false memories of a past that never happened, floating in the void for a fleeting second before dissolving back into chaos. This entity is called a Boltzmann brain. And here is the trap. If you accept the laws of statistical mechanics, then Boltzmann brains should vastly outnumber real evolved biological brains like ours. For every one real human living on Earth, there should be trillions of spontaneous brains hallucinating that they are living on Earth simply because it is easier for the universe to make a mistake than to make a history. This forces you to ask a question that you cannot answer. Are you a real person with a real past born of parents and aging through time? Or are you a Boltzmann brain that fluctuated into existence 1 second ago with a complex set of fake memories regarding a childhood, a family, and a video about time paradoxes that you think you have been watching for the last 2 hours? The Boltzmann brain paradox is not just a spooky ghost story, it is a reductio ad absurdum that threatens to undermine all of science. If we are Boltzmann brains, then our memories are lies, which means our knowledge of physics is a lie. The textbooks we remember reading, the experiments we remember conducting, and the history of science we cherish never actually occurred. They are just random data patterns encoded in our fleeting neural networks. This leads to a state of cognitive collapse called epistemological skepticism, where we cannot trust anything we think we know, including the argument that led us to believe in Boltzmann brains in the first place. Cosmologists take this problem very seriously because it suggests that our current theories of the universe are fundamentally flawed if our theory predicts that we are likely random fluctuations, but we observe that we are seemingly in a stable, orderly universe. Then the theory must be wrong. Usually, the counter-argument relies on the fact that we see a vast, orderly universe around us, not just a chaotic void, but a Boltzmann brain would also hallucinate a vast, orderly universe, so looking out the window proves nothing. The only way to defeat this paradox is to assume that the universe is not infinite in time, or that it will end relatively soon, preventing the accumulation of these random nightmares. This connects directly to the arrow of time and the low entropy state of the Big Bang. Explaining why the universe started in such an orderly state is the only way to ensure that we are real observers and not quantum accidents. Essentially, the validity of your own existence depends on understanding why time flows from the past to the future. If that flow is just a statistical accident, then you are likely an accident too. A lonely mind, dreaming of a world that does not exist, suggesting that the greatest paradox of time is not what happens when it ends, but whether the past it seemingly created is nothing more than a fiction written by chaos. We have now stared into the deepest abyss that modern physics has to offer, and the reflection looking back is unrecognizable. We started by thinking that time was a simple river carrying us forward, but Act 2 has revealed that the river is a hallucination. We have seen that observation can freeze time like a stopped clock, that the future can reach back and steer the past, and that black holes threaten to delete the very information that makes up reality. We have grappled with the idea that our three-dimensional world is a flat hologram, that time might be an emergent illusion created by quantum entanglement, and that we might all be momentary brains floating in a vacuum, dreaming of a life that never was. We have deconstructed the machinery of reality and found that the gears do not mesh. Usually when science breaks a concept down, it rebuilds it into something stronger. But with time, the deeper we look, the more it seems to evaporate, slipping through our fingers like sand, leaving us with a static, frozen universe or a chaotic probability soup. Yet, as terrifying as these quantum and theoretical nightmares are, they are largely problems of the mind and the very small. There is one final challenge remaining, a challenge that is not about illusions or probabilities, but about the inevitable brute force of destiny. We must now turn our eyes from the microscopic weirdness of the atom to the macroscopic majesty of the cosmos. We must look forward to the deep future, where the arrow of time flies toward its final target. Ultimately, it does not matter if time is a hologram or a block universe, if the stage itself is destroyed. Even a timeless universe has a lifespan. And as we enter the third and final act of our journey, we will confront the ultimate fate of all things. The heat, death, the big rip, and the eternal return, showing that while time might be an illusion, the end is terrifyingly real. We enter the final act of our tragedy with a concept that transforms the idea of eternity from a comforting promise into a claustrophobic cage. This is the theorem of Poincare recurrence, named after the French mathematician Henri Poincare, who proved a fact about dynamical systems that is as simple as it is terrifying. Usually, when we think about the future of the universe, we imagine a straight line stretching out forever into new and unknown territories. We assume that tomorrow will be different from today, and that the next millennium will bring things that have never happened before. But Poincare showed that if you have a system with a finite amount of energy and a finite volume confined within a limited space, it cannot evolve into new states forever. Eventually, it must run out of options. To understand this, imagine a very large box filled with gas molecules. These molecules are zooming around, crashing into each other, and bouncing off the walls in a chaotic dance. At any given second, the molecules are arranged in a specific pattern, a specific configuration. Strictly speaking, there is a colossal number of possible patterns, but crucially that number is not infinite. It is just very, very large. Eventually, if you wait long enough, the molecules will exhaust every single possible arrangement they can take. Once that happens, the system has no choice but to start repeating itself. The molecules will inevitably find themselves back in the exact same positions with the exact same velocities that they had at the start of the experiment. Now apply this logic to the entire universe. If our cosmos is finite in volume and contains a finite number of atoms, which many cosmological models suggest is true, then the universe is just a very large box of gas. The particles that make up your body, the air you breathe, the screen you are looking at, and the stars in the sky are just shifting into different temporary configurations. Given an infinite amount of time, these particles will eventually run through every single possible permutation of reality, implying that the state of the universe right now, including you, sitting there listening to these words, is not a unique event. It is simply one frame in a finite reel of film that is being played over and over again. The mathematics dictates that a time must come known as the Poincare recurrence time, when the atoms of the universe will once again arrange themselves exactly as they are right now, reconstructing this moment, and reconstructing your entire history down to the last neuron firing in your brain. This is not a probability. It is a certainty if the laws of mechanics hold true, proving that in a closed universe, history is not a line, but a circle. The timescale for this to happen is so vast that it defies human language calculated to be roughly 10 to the power of 10 to the power of 10 to the power of 56 years, a number so large that if you tried to write it down, the ink would fill the observable universe before you finished the zeros. But in the face of true infinity, even this monstrous number is nothing. It is a blink of an eye. This means that you have lived this life before an infinite number of times, and you will live it again. An infinite number of times, there is no escape from your biography. Every joy, every sorrow, every mistake, and every triumph is permanently etched into the cycle of matter, forcing us to confront the possibility that we are trapped in a cosmic Groundhog Day from which there is no waking up, making the concept of an end of time seem like a mercy we might never be granted. The mathematical certainty of recurrence transforms physics into the deepest existential horror imaginable, a concept that the philosopher Friedrich Nietzsche called the eternal return or the heaviest burden. While Poincare provided the mathematical proof, Nietzsche explored the psychological devastation of this idea. He asked us to imagine a demon creeping into our loneliest loneliness and whispering to us this life. As you now live it and have lived it, you will have to live once more and innumerable times more, and there will be nothing new in it. But every pain and every joy and every thought and sigh and everything unutterably small or great in your life will have to return to you all in the same succession and sequence. Usually, we comfort ourselves with the idea that our suffering is temporary, that embarrassing moments fade, and that pain eventually ends, giving way to peace. But the eternal return strips us of this comfort. It declares that your suffering is eternal, that the moment of your death is not a finale, but a transition back to your birth. Consider the implications for meaning and regret. If you make a mistake today in a linear universe, it is just one mistake, a lesson learned, but in a recurring universe, that mistake is an infinite feature of reality, a statue carved in time that you must walk past forever. This perspective changes the weight of every single action you take right now. If you choose to be cruel, that cruelty will echo through eternity, repeated without end. If you choose to be brave, that bravery becomes an eternal monument. Nietzsche argued that this thought is the ultimate test of life affirmation. He challenged us to live in such a way that we would want to repeat the same life eternally to love our fate, so deeply known as amor fati that we would scream yes to the demon. Imagine the strength required to accept that your life, with all its boredom, tears and tragedies, is worth repeating infinite times without changing a single detail. However, for most of us, this is not a source of strength, but of paralysis. It turns the universe into a hell of absolute determinism, where nothing can ever be fixed or improved. It implies that progress is an illusion. We are not moving toward a better future, we are simply walking in circles on a track, worn down by our own footsteps countless times, before the hope of a finale, of a heavenly rest, or a peaceful oblivion is shattered, replaced by the crushing machinery of exact repetition, forcing us to ask if consciousness is a gift or a curse. If we are doomed to be the watchers of a movie we cannot turn off and cannot edit forever, locked in the prison of our own identity. If the prospect of living forever in a loop feels too suffocating, let us look at the alternative scenarios where the universe breaks out of the cycle by destroying itself completely. The first, and perhaps the most violent of these endings, is known as the Big Rip, and it is driven by the mysterious force we call dark energy. For most of cosmic history, gravity acted as a brake, slowing down the expansion of the universe, pulling galaxies together. But about 5 billion years ago, something changed. A repulsive force inherent to empty space began to push back harder than gravity, pulled, effectively hitting the accelerator on cosmic expansion. Today, we know that the universe is not just expanding, it is expanding faster and faster every second. The Big Rip hypothesis arises if this dark energy is essentially a phantom energy with an equation of state parameter W less than -1. In simple terms, this means that the density of dark energy increases as the universe expands, creating a runaway feedback loop as space grows. There is more dark energy which pushes space apart faster, which creates even more dark energy. Eventually, this force becomes so powerful that it overwhelms every other force in nature, tearing apart structures that we thought were indestructible. The timeline of the Big Rip is a countdown to total isolation. First, about 60 million years before the end, the expansion becomes so fast that gravity can no longer hold the Milky Way together. Our galaxy is stripped apart, sending stars flying off into the void alone, essentially, dissolving the spiraling city of lights into a scattered debris field. Then, about 3 months before the end, the solar system is torn asunder. The dark energy pushes the Earth away from the Sun, effectively unbinding the planets from their orbits, leaving our world drifting in cold darkness. But the horror does not stop at gravity in the last 30 minutes. The planet itself explodes as the repulsive force overcomes the chemical bonds holding rocks and magma together. In the final fraction of a second, the destruction reaches the atomic scale. The space inside atoms expands faster than light, ripping electrons away from nuclei, and then shredding the protons and neutrons themselves into their constituent quarks. Finally, at the moment of the Big Rip, the fabric of space-time itself is torn apart, leaving a singularity of infinite expansion, everywhere at once. In this scenario, time does not just stop, it is shredded along with space, leaving absolutely no structure, no memory, and no possibility of recurrence. It is the ultimate deletion, a violent scream that silences the universe forever, ensuring that nothing, not even the atoms of your body, can survive to tell the tale. At the opposite end of the spectrum from the Big Rip lies the Big Crunch, a scenario that was once the leading theory of cosmic doom and still haunts the mathematics of cosmology, while current data suggests expansion is winning. If dark energy weakens or reverses over time, gravity could inevitably regain the upper hand. Imagine a ball thrown into the air. Eventually it must stop rising and fall back down. Similarly, the expansion of the universe could slow to a halt and then begin to contract, bringing all the galaxies rushing back together toward a single point. This process would be terrifying to witness. The sky would shift from black to red as the light from distant stars gets blue shifted by their approach, essentially cooking the universe in high-energy radiation. The cosmic microwave background, the cold afterglow of the Big Bang would heat up until space itself becomes hotter than the surface of a star, roasting planets and vaporizing all life. Long before the walls close in, but the most mind-bending aspect of the Big Crunch is what it might do to time itself. Physicist Thomas Gold proposed a theory in the 1960s, suggesting that the arrow of time is linked to the expansion of the universe. If this is true, then as the universe contracts, the arrow of time would reverse. Imagine living in a world where the future is the past. Broken cups would leap off the floor and seal themselves. Currents would flow from cold to hot, and we would remember the future while forgetting the past. In this mirror universe, people would rise from their graves, grow younger, and eventually return to the womb, essentially living their lives in reverse. This sounds like pure fantasy, but in a completely deterministic universe governed by symmetrical laws, it is a valid solution to the equations. However, most modern physicists argue that entropy would continue to increase even during a collapse, creating a messy, hot chaos rather than a neat rewinding of the movie. Ultimately, the Big Crunch leads to a singular point where all the matter in the cosmos is squeezed into zero volume. A reverse Big Bang where the density becomes infinite and the laws of physics break down completely, In this final moment, known as the Big Squeeze, time effectively runs out of space to exist in compressing all of history into a single dimensionless dot, ending the story of the universe, not with a whimper, but with a crushing implosion that obliterates the distinction between the beginning and the end. While the Big Rip and the Big Crunch are dramatic, violent endings, the most likely fate of our universe, according to current measurements, is far slower, far quieter, and in many ways, far more disturbing. It is called the heat death or the Big Freeze, and it is the direct consequence of the second law of thermodynamics. As we discussed earlier, entropy always increases, which means the universe is constantly moving from a state of useful concentrated energy to a state of useless scattered energy. Think of the universe as a battery that was fully charged at the Big Bang. Every star that burns every planet that turns, and every thought you think is slowly draining that battery, converting potential energy into waste. Heat. The tragedy of the heat. Death is that energy is never actually destroyed. It is just degraded. When a star burns, it turns hydrogen into helium and heat. That heat radiates out into the void and becomes thinned out, spreading across billions of light years. Eventually, it becomes so spread out that it can never be gathered back together to do useful work. It is like pouring a cup of hot water into the ocean. The energy is still there in the ocean, but you can no longer use it to brew tea or drive an engine slowly. But surely, the universe is sliding toward a state of thermodynamic equilibrium, where everything is at the exact same temperature, just a fraction of a degree above absolute zero. In this state of maximum entropy, no processes can occur, no stars can form, no life can survive, and no clocks can tick, because a clock needs a flow of energy to measure time. Time itself loses its meaning when nothing changes. Usually we define time by events. A sunrise, a heartbeat, a movement. But in the heat, death, there are no events. Just an endless stagnant lake of cold photons and drifting particles. The universe does not end with a bang. It simply falls asleep and never wakes up. It becomes a cosmic graveyard where the corpses of stars float forever in the dark, perfectly preserved in a tomb of silence, infinite in duration, but zero in significance, making the heat death not just the end of life, but the end of possibility itself. To truly grasp the horror of the heat, death, we must walk through the timeline of the future. A journey that spans years so numerous they dwarf the age of the current universe into a fleeting spark. Physicists divide this deep future into eras of decay, each one darker and emptier than the last. Right now, we are living in the stelliferous era, the age of stars, which is the energetic peak of cosmic history. But this era is essentially a brief fireworks display that will soon burn out in about 100 trillion years. The very last star will be born. It will be a small red dwarf, barely glowing against the encroaching blackness when it dies. The universe will enter the degenerate era. In this grim epoch, the only objects remaining will be the cooling corpses of stars. White dwarfs, neutron stars, and brown dwarfs. The night sky will be pitch black, visible only to instruments that can detect the faint infrared heat of these dying embers. Occasionally, two of these corpses might collide, creating a brief flash of light, a ghostly echo of the vibrant universe that used to exist. But these flashes will be rare, separated by eons of darkness. Civilizations, if any survive, will huddle around the last spinning black holes, trying to harvest their rotational energy like freezing travelers huddled around a dying campfire, begging for a few more moments of warmth before the inevitable cold takes them. But even the corpses of stars are not immortal. Physics predicts that protons, the building blocks of atomic matter, may be unstable over vast timescales. Roughly 10 to the power of 34 years in this distant future, the matter that makes up the dead stars and planets will simply begin to dissolve. The protons will decay into positrons and gamma rays, meaning that the solid objects of the universe will evaporate into radiation. Imagine whole planets slowly turning into ghosts and fading away until there is no solid ground left anywhere. Eventually, the universe will enter the black hole era, where the only organized structures remaining are black holes, giant monsters that have consumed everything else, dominating a universe of dust. Yet even these titans must die due to Hawking radiation. Black holes will slowly leak their mass back into the void, shrinking over timescales of 10 to the power of 100 years. The largest black holes will take googles of years to evaporate, but eventually they too will vanish in a final burst of gamma rays, leaving the universe in the dark era, a void containing nothing but a thin mist of photons, neutrinos, and electrons, separated by distances so vast that they will never interact with each other again. In this final state, the universe is effectively empty, a hollow shell expanding forever into nothingness, where the concept of time has been stripped of all landmarks, leaving only a featureless eternity of zero, after the last proton has decayed and the final remnants of solid matter have dissolved into a fine mist of radiation. The universe enters what cosmologists call the black hole era. This is a period of time so incomprehensibly vast that it makes the entire history of stars and galaxies look like a single flash of a camera shutter in a featureless night. Right now, we live in the era of light, where stars actively turn fuel into energy, but in this distant future, the universe will be a graveyard populated solely by the gravestones of its former giants. The black holes, these monsters having consumed everything within their gravitational reach, will drift in absolute solitude through a cosmos that has expanded to such a degree that no two black holes will ever likely cross paths again. Imagine a universe where the nearest object to you is not light years away, but trillions of billions of light years away, a distance so great that light itself would take eons to cross it, leaving each black hole effectively alone in its own private observable universe. However, even these titans of gravity are not immortal. They are subject to a slow and agonizing death caused by the laws of quantum mechanics, specifically a process discovered by Stephen Hawking in 1974, known as Hawking radiation. In the crushing emptiness of space, the vacuum is not truly empty. It is seething with virtual particles, pairs of matter and antimatter that pop into existence, borrow a tiny amount of energy from the vacuum, and then collide and annihilate each other, returning the energy almost instantly. Usually, this dance of phantom particles has no effect on the macroscopic world, but at the very edge of a black hole, the event horizon, this dance becomes a mechanism of destruction. One particle of the pair falls into the black hole, while the other escapes into space, stealing a tiny fraction of the black hole's mass in the process. This means that black holes are constantly evaporating, bleeding their energy out into the cold void, particle by particle. The tragedy of this era is the sheer scale of the time it takes for this evaporation to complete a solar mass. Black hole will take approximately 10 to the power of 67 years to evaporate a supermassive black hole, giving up the ghost of a galaxy. Like our Milky Way might take 10 to the power of 100 years, known as a Google years, to grasp this number. Imagine a clock that ticks once every trillion years. Even if you let that clock tick until the battery dies, you would not even have scratched the surface of the black hole era during this almost infinite stretch of time. The universe is essentially doing nothing but waiting for its gravediggers to die. The darkness is absolute, save for the incredibly faint and cold glow of the Hawking radiation, which is far too weak to be seen by human eyes, essentially invisible energy leaking into an infinite container. Yet the death of a black hole is not entirely silent. As the black hole shrinks, it gets hotter and radiates faster, adhering to the strange thermodynamic laws of gravity for millions of eons. It emits only cold radio waves, but in the final moments of its life, when it has shrunk to the size of a proton, it releases all its remaining energy in a violent explosion, equivalent to millions of nuclear bombs detonating at once for a brief second. A flash of hard gamma rays will illuminate the dark sector of the universe. A final scream of a dying monster echoing in the silence, but with no one there to see it. This flash serves only as a herald of the end, marking the transition from a universe that still contained concentrated energy to a universe of total thermodynamic equilibrium. Slowly but surely, one by one, the lights will go out across the infinite expanse until the last black hole explodes and the universe is plunged into the dark era, proper a state of final and absolute entropy from which there is no return. When the last black hole has evaporated, the universe enters the dark era, also known as the photon age or the Great Void. This is the final chapter of physical reality as we understand it, and it represents a state of desolation that challenges the very definition of existence. At this stage, the cosmos contains no atoms, no protons, no neutrons, and no black holes. It is a soup of extremely diffuse particles, mostly photons, neutrinos, and perhaps a few stray electrons and positrons resulting from previous decays. These particles are scattered so thinly that the distance between them is greater than the size of our current observable universe. Imagine a single electron floating in a void of total darkness with absolutely nothing else. For billions of light years in any direction, it will never collide with another particle. It will never interact with a force field. It will simply drift forever in a straight line through a space that is expanding faster than the speed of light. In this era, the concept of temperature loses its meaning. The universe cools down to a state indistinguishable from absolute zero. The photons that were released by the Big Bang and the dying stars have been stretched by the expansion of space until their wavelengths are larger than the size of galaxies, becoming so low in energy that they are essentially undetectable ghosts passing through the void without leaving a trace. This is the heat death in its ultimate. Form a state where the entropy is maximized and the arrow of time effectively breaks, because there are no events to distinguish the past from the future. If you were to take a snapshot of the universe in the dark era and compare it to a snapshot taken 1 trillion years later, they would look mathematically identical, just a random distribution of cold particles in a vacuum. Nothing happens, nothing changes, and nothing evolves. However, there is a bizarre theoretical possibility that suggests a final ghostly form of matter might exist in this epoch known as Positronium. If a stray electron and a stray positron manage to find each other in the vastness of the dark era, they might not annihilate immediately. Instead, they could enter an orbit around each other, forming an atom of positronium, seemingly creating a new form of matter. But because the universe has expanded so much, the orbit of these two particles would be colossal, larger than our current solar system. These spectral atoms would spiral inward incredibly slowly, taking roughly 10 to the power of 140 years, to finally collide and annihilate in a burst of gamma rays. This unimaginable timescale makes the age of black holes look like a brief instant, proving that the universe creates structures even in its death throes. But these structures are merely delayed echoes of a bygone reality. Ultimately, the Dark Era confronts us with the definition of nothingness. Philosophers have long debated why there is something rather than nothing, but the physics of the far future suggests that something eventually becomes nothing. The void of the Dark Era is not the empty stage of Newtonian physics waiting for actors to enter it. It is a ruined stage where the actors have dissolved into the floorboards. Matter, energy, and time are stripped of their complex relationships, leaving only the bare mathematical bones of space. The universe effectively forgets it ever existed, erasing the monuments of civilization, the beauty of the nebula, and the complexity of life, leaving only a silent, expanding sea of vacuum energy that stretches on for true infinity, a final state of perfection where no error, no pain, and no consciousness can ever arise again. Just when the picture of the future seems most hopeless, emerging from the darkness is one of the most brilliant and radical ideas in modern physics proposed by the Nobel laureate, Sir Roger Penrose. His theory, known as conformal cyclic cosmology, begins with a profound question. What does it actually mean to keep track of time or distance in a universe that contains no mass? Usually, we measure time using clocks, and every clock in existence, from a swinging pendulum to a vibrating atom, relies on mass to function. The mass of the pendulum, bob, determines its swing, and the mass of the electron determines its frequency without mass. There is no frequency without frequency. There is no tick, and without a tick, there is no time. Similarly, We measure distance using physical objects. A ruler is made of atoms. A light year is defined by the speed of light interacting with matter. But in the dark era, as we have seen, all massive particles like protons and electrons have likely decayed or annihilated, leaving only photons. Here lies the key insight. Photons are massless particles traveling at the speed of light. According to relativity, a particle moving at the speed of light does not experience time from the perspective of a photon. The moment it is emitted and the moment it is absorbed are the exact same instant. Billions of years and billions of miles are compressed into zero duration for a creature made of light. Therefore, if the universe contains nothing but photons and gravitons, which are also massless, it loses the ability to perceive time and distance. The universe becomes scale invariant, which means it no longer knows how big it is. This sounds like a trivial geometric curiosity, but it has shattering implications for the fate of reality. Imagine two pictures on a computer screen. One shows a simple fractal pattern and the other shows the same pattern zoomed in 1 trillion times because the pattern is fractal self. Similar at all scales, you cannot tell which one is the zoomed in version without a reference object like a banana or a ruler placed next to it in the deep future. The universe loses all its reference objects. There are no rulers left. This leads to a paradox that might save us from eternal nothingness if the universe forgets how big it is. Then, the distinction between being infinitely large, which is the state of the heat death, and being infinitely small, which is the state of the Big Bang, disappears completely in the rigorous language of conformal geometry. A stretched out infinite cold universe is mathematically identical to a hot, dense, point-like singularity provided. There is no mass to break the symmetry. This suggests that the heat death is not the end of the story, but a geometric trick of perspective as the universe expands into infinity and the last massive particles vanish. The fabric of spacetime loses its rigidity. The cold, vast emptiness of the future effectively morphs into the hot, dense seed of a new beginning. The concept of huge and the concept of tiny merge into one simply because there is no one left to measure the difference. This is the ultimate act of cosmic forgetting, where the universe sheds the burden of its physical history, and in doing so resets the clock back to zero, creating the conditions for a new Big Bang, not from a random fluctuation, but from the inevitable geometric consequence of its own death, transforming the tomb of the old eon into the cradle of the new one. To visualize this transition from the end of time to a new beginning, we must embrace the metaphor of cosmic amnesia. Imagine the universe as an old man who has lived a long and complex life, full of memories, structures and scars. Over time, he begins to forget his memories, fade, his possessions turn to dust, and his sense of self dissolves. Eventually, he reaches a state of total forgetfulness where he no longer knows his name, his age, or his history in human terms. This is a tragedy, a loss of identity, but in cosmic terms, this total forgetting is a necessary cleansing fire. Precisely because the universe forgets its size and its age, it creates a tabula rasa, a blank slate upon which a new story can be written. Without this amnesia, the universe would be cluttered with the debris of the past, entrapped by the entropy of the old era, unable to start fresh. The transition moment itself, which Penrose calls the crossover, is a bridge across eternity. On one side of the bridge is the aeon. We know our current universe expanding and dying. On the other side is a new aeon, a fresh Big Bang. The mathematics describing this crossover implies that the boundaries of the universe are not solid walls, but conformal boundaries that can be glued together. Simply put, the infinity of the future is glued to the singularity of the past, creating a continuous cylinder of cycles. This means that what we perceive as the Big Bang, the explosion that created us, was not the beginning of time itself, but merely the moment when the previous universe finished its process of forgetting and woke up with no memory of what came before. This metaphor shifts our perspective on entropy. Usually we see entropy as the enemy, the force that degrades order and kills life. But in the context of cyclic cosmology, entropy is the tool that clears the stage. The second law of thermodynamics drives the universe toward the heat death. Specifically, a wipe the slate clean, enabling the geometry to reset it, is like a forest fire that burns down the old, choking undergrowth to allow new saplings to rise from the ashes, or a farmer ploughing the dead stalks of last year's harvest into the soil to feed the seeds of next spring. In this view, the heat death is not a mistake or a failure of the laws of physics. It is a vital part of the cosmic reproductive cycle, a winter that must occur so that a new summer can follow, suggesting that the universe is not a machine that runs down and breaks, but a living, breathing entity that renews itself through the mechanism of its own demise. However, this rebirth comes with a heavy philosophical price for the new universe to be born. The old one must be completely erased. This means that no information, no history, and no legacy from our current existence can survive the crossover. We cannot send a message to the future inhabitants of the next aeon, warning them about nuclear war or telling them that we existed. Our art, our science, and our struggles are destined to be wiped from the hard drive of reality, ensuring that the new observers will wake up in a fresh mystery, completely unaware that they are walking on the ashes of giants. This is the ultimate humility, enforcing the idea that while life might be eternal, individual civilizations are fleeting sparks in the night, meaningful only to themselves in their own brief moment of time. The theory of conformal cyclic cosmology sounds like a beautiful philosophical dream or a piece of science fiction. But Roger Penrose is a mathematical physicist, not a poet, and he argues that this theory makes testable predictions that can be verified by observing the real universe. If our Big Bang was the result of a collision between the previous dying aeon and our current one, then that collision should have left a mark, a scar, on the face of the cosmos. Specifically, Penrose suggests that we should look for signals from the colossal black holes that dominated the dark era of the previous universe. When those ancient supermassive black holes collided or evaporated, they would have released unimaginable amounts of energy in the form of gravitational waves. Usually, we think of gravitational waves as faint ripples, but the waves from entire galactic clusters colliding would be tsunamis in the fabric of space-time. These waves would ripple through the crossover boundary and affect the distribution of matter in the new Big Bang, creating circular patterns of slightly higher or lower temperatures in the cosmic microwave background, radiation, the afterglow of creation that we can detect today. Penrose calls these scars Hawking points, and he claims to have found them. In analyses of data from the Planck satellite and the WMAP spacecraft, Penrose and his colleagues identified concentric circles in the cosmic microwave background, where the temperature variance is much lower than the standard model of cosmology predicts. They argue that these rings are the ghost signals, the echoes of black hole collisions that happened eons before our universe even began, if this turns out to be true. And it remains a subject of intense debate among cosmologists. It would be the first physical evidence that time did not start 13.8 billion years ago. Instead, it would prove that we are living in just one of an infinite chain of aeons, a single chapter in a book that has no beginning and no end. This offers a strange and melancholic form of hope. It is not the personal hope of an afterlife or the survival of humanity, but the abstract hope that existence itself is tenacious, that the lights never truly go out forever, even if the heat death wipes us out. The underlying machinery of the universe guarantees that physics and complexity will rise again. The dead silence of the void is not a permanent state, but a pregnant pause, a breath taken before the next plunge into creation. It suggests that the paradoxes of time we have explored, the loops, the stops, the reversals, are all symptoms of a reality that is far more flexible and resilient than our linear intuition allows, essentially telling us that while our time is limited, time itself is a phoenix continuously rising from the ashes of its own destruction, ensuring that the story of the universe is never truly over. While Penrose suggests that our universe is a reincarnated version of a single eternal ancestor, reborn from its own ashes, physicist Lee Smolin proposes an even more biological and radical idea known as cosmological natural selection. This theory takes the principles of Darwinian evolution, mutation inheritance, and survival of the fittest, and applies them not to animals or plants, but to entire universes. According to this view, the singularity at the center of a black hole is not a dead end or a trash can where information goes to die, but rather a reproductive organ, a birth canal for a baby universe. Imagine that when a star collapses and forms a black hole, the extreme pressure and density do not just crush matter into oblivion, but instead punch a hole through the fabric of space-time, creating a bubble that expands into a new dimension, effectively becoming a separate universe, disconnected from ours. The genius of Smolens's theory lies in the mechanism of inheritance. He suggests that the laws of physics in this new baby universe are not random. Instead, they are slightly mutated versions of the laws from the parent universe, just as a child inherits DNA from their parents with tiny variations. The physical constants of the baby universe, the mass of the proton, the strength of gravity, the speed of light, are similar to, but slightly different from those of the black hole that birthed it. This introduces the concept of evolutionary pressure to cosmology. Universes that have laws of physics capable of producing stars will naturally produce more black holes, because stars are the precursors to black holes. Consequently, these fertile universes will have more offspring, passing on their star-friendly physical laws to the next generation. On the other hand, universes with laws that prevent star formation, perhaps gravity is too weak to pull gas together, or the nuclear force is too strong, making fusion impossible, will be sterile. They will not produce black holes, and therefore they will not reproduce. Their lineage will die out, just like a species that fails to adapt to its environment over billions of cosmic generations. This process of natural selection would fill the multiverse with universes that are finely tuned to produce as many black holes as possible. This explains one of the greatest mysteries in science: why our universe seems so perfectly constructed for complexity and life. Usually we attribute this to luck or a creator, but in Smolens's view, we live in a complex universe simply because complex universes are the best survivors, the most fecund breeders in the cosmic population. This implies that we are not the intended purpose of the universe, but merely a byproduct. Essentially, we are the parasites living inside the reproductive cells of a cosmic superorganism. The stars in our sky are not there to light our way or to provide energy for life. They are there to collapse and create more black holes to ensure the survival of our physical lineage. This perspective shifts our place in the cosmos from the center of attention to a side effect of a vast evolutionary process, suggesting that time is not just a line or a cycle, but a branching tree of life growing wildly in a superspace. We can never see where every black hole is a seed, waiting to germinate into a new reality populated by its own stars, its own observers, and perhaps its own theories about where it came from, making the flow of time a mechanism for the survival of physical law itself. As we consider these vast cycles of birth, death, and rebirth, whether through Penrose's loops or Smolens's trees, we are forced to confront a statistical anomaly that is deeply personal and unsettling. Usually, the Fermi paradox asks if the universe is so big, why do we not see aliens? But there is a temporal version of this paradox that asks if the universe is so old and will last so long, why do we exist right now? Consider the timeline we have just explored, the stelliferous era. The time when stars shine and life is possible is an incredibly thin sliver of light, sandwiched between the Big Bang and the eternal dark era. Mathematically speaking, the period in which life can exist represents less than 0.000001% of the total lifespan of the universe, essentially a single flash of a camera in a movie that lasts for 1 billion hours. If you were to pick a random moment in the history of the universe to be born simply by throwing a dart at the timeline, you would almost certainly land in the degenerate era or the black hole era. You would be born into a cold, dark void where no stars shine and no chemistry is possible. The fact that we find ourselves alive in this incredibly brief golden age when the universe is warm, bright, and rich in heavy elements feels like winning the lottery 1 trillion times in a row. This is often called the problem of temporal provincialism, implies that we are special or that our existence is somehow privileged, which makes scientists very uncomfortable because the Copernican principle tells us we should be average observers in a typical environment. One solution to this paradox is the weak anthropic principle, which simply states that we are here now because we could not be here later. Observers can only exist when the conditions allow for observation. So obviously, we find ourselves in the habitable era, but this answer feels unsatisfyingly circular, like saying, you are in the house because you are not outside a darker solution, suggests that we are here now, because civilization is extremely fragile and typically destroys itself before the universe gets old. This implies that the reason we do not see observers in the deep future or the deep past is that intelligent life is a flash in the pan, a fleeting spark that ignites, consumes its resources and burns out almost instantly, never lasting long enough to witness the long dark winter of the cosmos. This realization adds a layer of precious urgency to our current moment. It suggests that we are the guardians of the only meaningful time in history. We are the eyes of the universe during its brief moment of awakening before it slips back into an eternal coma. The beauty we see around us, the spiral galaxies, the nebulas, the blue planets, is not the norm. It is a momentary aberration, a rare fluctuation of order in a reality that is overwhelmingly dominated by chaos and cold. This makes our time our now the most valuable resource in existence. Vast oceans of time lie ahead, but they are barren and empty. We are the inhabitants of the island of light, and the knowledge that this island will inevitably sink beneath the waves of entropy makes our presence here not just a statistical fluke, but a cosmic responsibility to witness, to understand, and to remember before the lights go out forever. We have spent hours discussing how time bends, breaks, and ends, but we have yet to answer the most fundamental question: what is time made of? We assume time is a fundamental part of the bedrock of reality, like space or mass, but the Italian theoretical physicist Carlo Rovelli proposes a mind-bending alternative known as the thermal time hypothesis. He argues that at the deepest level of reality, the level of quantum loops and spin networks, time does not exist at all. The equations that describe the fundamental architecture of the universe do not contain a variable for time. The universe at the bottom is just a network of relationships determining how physical fields interact with each other, without any reference to a clock or a sequence of events. So where does the flow of time come from? Rovelli suggests that time is an emergent phenomenon inextricably linked to our ignorance of the microscopic details. Essentially, time is the result of our inability to see the universe clearly. Imagine looking at a glass of water from a distance. It looks like a smooth, transparent liquid. This smoothness is a macroscopic description, but if you looked at it with a super microscope, you would see billions of chaotic water molecules bouncing around furiously with no smoothness at all. The smoothness is not a property of the water, it is a property of your blurred vision. Similarly, Rovelli argues that what we perceive as the flow of time is just the blurring of the quantum chaos. In thermodynamics, heat is the random motion of particles. We cannot track individual molecules, so we average them out and call it temperature. Rovelli shows mathematically that in a system where you cannot track the microstates, a variable naturally emerges that creates an ordering of events. This variable behaves exactly like time. This means that time is literally a form of heat, a statistical artifact that appears only when you deal with large, complex systems and ignore the details. If you were a demon capable of seeing and tracking every single quantum particle in the universe. Simultaneously, time would vanish, the past, present, and future would dissolve into a single static network of correlations, and the flow would stop. This theory, thermal time, implies that time is subjective, not in a psychological sense, but in a physical sense. It depends on the observer's relationship to the system. If we had perfect information, there would be no time. Time is the shadow, cast by our limitations. It is the price we pay for being macroscopic creatures who cannot handle the infinite complexity of the quantum world. This is a humbling and terrifying conclusion. It suggests that the most powerful force in our lives, the force that ages us and kills us, is not a fundamental law of nature but a side effect of our own blurry vision, a consequence of the fact that we are too big and too slow to see reality as it truly is, purely timeless and eternal. If time is a physical illusion generated by entropy and quantum blurring, then our perception of it is a biological hallucination generated by the brain. We trust our senses to give us a live feed of reality like a camera streaming video to a screen, but neuroscience reveals that we are always living in the past, simply because it takes time for neural signals to travel from your eyes and ears to your visual and auditory cortex. Processing a visual image takes the brain about 80 milliseconds, roughly 1/10 of a second, while processing sound is slightly faster. This means that if your brain presented reality to you exactly as it arrived, you would experience the world like a badly dubbed movie where the lips move before the words are heard. To prevent this disorienting chaos, the brain pulls a clever trick. It waits. It collects all the sensory inputs, holds them in a buffer for a fraction of a second, stitches them together into a coherent package, and then presents them to your consciousness stamped with the label. Now this means that the moment you think is happening right now actually happened. About 80 milliseconds ago, you are permanently lagging behind reality, trapped in a delay loop, created by your own nervous system. Furthermore, the brain actively edits this feed to remove inconsistencies, creating the illusion of a smooth, continuous flow where none exists. A famous example of this is the stopped clock illusion or chronostasis. Imagine you quickly glance at a ticking analog clock. Often the second hand seems to freeze for a moment longer than a second before continuing its tick. This happens because during the rapid movement of your eyes known as a saccade, your visual input is blurry and useless to avoid showing you a blur. The brain essentially cuts that part of the video out and fills the gap with the image of the clock that you see after your eyes stop moving, stretching that image backward in time to cover the edit. This proves that your perception of duration is a construct, a flexible story. Your brain tells you not a measurement of a physical quantity. But why does the brain do this? The answer is survival. We did not evolve to understand quantum mechanics or the block universe. We evolved to catch prey and avoid predators for an organism. Survival depends on prediction, not just passive observation. The brain is essentially a prediction engine constantly projecting a model of the immediate future based on the past, allowing you to catch a ball or dodge a rock. Essentially, your brain is a time machine that constantly projects you slightly into the future to compensate for the neural lag. This means that the sensation of time flowing is really the sensation of your brain constantly guessing what happens next. The flow is not out there in the stars. It is in here in the synaptic firing of a primate mind, trying desperately to stay in sync with a universe that is moving too fast for it to comprehend. The ultimate irony of our existence is that while our brains construct a smooth flow of time to help us survive, our bodies are fighting a losing war against the very source of that time entropy. We discussed how the arrow of time is driven by the universe's tendency to move from order to disorder. Biologically speaking, life is a direct rebellion against this trend. The physicist Erwin Schrödinger, in his famous book, What is Life, described living organisms as islands of order in a sea of chaos. A rock left in the sun simply heats up and disperses its energy, passively obeying the second law of thermodynamics, but a living cell actively sucks energy from its environment, from food, from sunlight, to repair itself and maintain its complex structure, effectively pumping entropy out of its system to stay organized. This means that life is a localized reversal of the arrow of time we consume order to prevent ourselves from dissolving into the background hum of the universe. Every breath you take is a battle against equilibrium. because equilibrium for a biological system means death. When you die, the active pumps stop the barriers, break down, and your body rapidly succumbs to entropy, dissolving into the dust and gas from which it was made, reaching the same temperature as your surroundings, essentially becoming one with the chaotic flow of the universe. Therefore, our fear of time and death is not just a psychological quirk, it is a fundamental biological imperative, deeply wired into our cells. To be alive is to be in a state of constant tension, a tightrope walk above the abyss of thermodynamic decay. The flow of time we perceive is the friction of this struggle. It is the sensation of swimming upstream against a current that wants to wash us down into the ocean of heat, death. This reframes our entire existence, not as a passive journey through time, but as an active resistance against it. We are temporal anomalies holding onto our complexity for as long as our metabolism allows, defying the crushing weight of a universe that wants nothing more than to turn us into scattered atoms and cold radiation, making every second of life a victory against the inevitable mathematical end of all things. We have reached the summit of our long and terrifying journey, and now it is time to turn around and look back at the path we have climbed, to see the landscape of time in its entirety. When we started this investigation hours ago, we viewed time as a simple, reliable friend, a clock on the wall that ticks evenly for everyone, everywhere, giving structure to our days and meaning to our lives. But layer by layer and paradox by paradox, we have stripped away this comfortable mass to reveal the alien machinery beneath. We began with the shock of relativity, realizing that time is not a constant drumbeat, but a fluid that pulls around gravity and rushes past speed, where a twin can return younger than his brother, and a satellite must drift in time just to tell you where you are. Then, we descended into the logical madness of the loop, where causes and effects dance in circles, where information can exist without a creator, and where the past is not a closed book, but a destination that can be revisited. Rewriting the script of reality, we face the block universe of frozen crystal of 4 dimensions, where your birth and your death are etched side by side in the stone of eternity, denying you the freedom of a future that has not happened yet. We saw the arrow of time revealed not as a law, but as a tragedy. The statistical march of entropy dragging the universe from the complexity of life to the simplicity of dust, proving that the flow we feel is simply the sensation of the cosmos dying. We did not stop there. We plunged into the quantum basement where observation freezes time, where the future chooses the past, and where black holes threaten to delete the library of history, creating a paradox that breaks the laws of physics. We saw that our 3-dimensional reality might be a hologram, projected from the edge of the universe, that time might be an illusion of heat, generated by entanglement, and that the very stability of the vacuum is a lie, waiting to collapse. We confronted the nightmares of the deep future, the ripping apart of atoms, the crushing of the big squeeze, and the endless silence of the heat death. And finally, we saw the possibility of rebirth through the amnesia, of the dark era or the natural selection of black holes, suggesting that our aeon is just one breath in an infinite rhythmic breathing of the multiverse. This is not just a collection of random facts, it is a mosaic that tells a single overwhelming story. The story that our intuitive human understanding of time is fundamentally wrong. We are like flatlanders trying to understand a cube, or blind men trying to describe an elephant we grasp at the shadows cast by time, the ticking clock, the aging face, the setting sun. But the thing itself, the fundamental reality, remains hidden behind the veil of our biological limitations and our mathematical ignorance. We have learned that time is not a container for events. It is an event itself. It is not a stage for the actors. It is one of the actors, and it is playing a role that is far more complex, treacherous, and beautiful than we ever dared to imagine. So we return to the question that started it all. The question that scares scientists and philosophers alike: is time real, or is it an illusion? The answer that emerges from the synthesis of relativity, quantum mechanics, and thermodynamics is a subtle and profound compromise. Time is not fundamental, but that does not mean it is not real. Consider the color blue. An individual atom is not blue. A proton has no color and an electron has no color. Color is an emergent property that only exists when billions of atoms interact with light in a specific way, and a brain interprets that interaction. Just because you cannot find blue under a microscope does not mean the ocean is not blue. It means that blue is a property of the collective, not the individual. Time is exactly the same. It is likely that at the very bottom of reality, in the spin networks of loop quantum gravity or the strings of string theory, there is no variable. There is only a static network of relationships, but when you zoom out, when you aggregate trillions of quantum interactions, the pattern we call time emerges, just as heat emerges from the motion of atoms or sound emerges from the compression of air. Time is the heat of the universe's complexity. It is the sound of reality happening. It is the statistical blurring that allows us to make sense of the chaos. Without this blurring, without this emergent flow, we would be paralyzed by the infinite detail of the quantum world, unable to perceive cause and effect, unable to learn, and unable to survive. Therefore, time is a story that things tell each other. It is the protocol that allows matter to interact with matter across the gulf of space. It is real in the sense that it governs our lives, destroys our bodies, and dictates the fate of stars. But it is illusory in the sense that it is not a part of the bedrock of existence. It is a user interface generated by our specific perspective as macroscopic creatures living in a low entropy era of the universe. This realization should not induce despair, but awe. It means that we are creating time simply by existing and observing. We are the weavers of the narrative, binding the static moments of the block universe into a flowing river of experience, giving life to a reality that would otherwise be a frozen sculpture in the dark. If time is a temporary emergent phenomenon, and if it will eventually end in the heat, death, or the big rip, what is the point of it all? This is the final emotional hurdle. The dread of nihilism. Usually we seek meaning in permanence. We want our legacy to last forever, our statues to stand for eternity, and our souls to be immortal. But physics tells us that nothing is immortal, not even the protons in your atoms. This creates a crisis of meaning only if we stick to the mistaken belief that value depends on duration. But look closely at your own life. Diamonds are valuable because they are rare. Gold is precious because it is scarce. If diamonds were as common as gravel, they would be worthless. The same logic applies to existence itself. It is precisely because time is limited that it is valuable. It is because the party must end that the music sounds so sweet. Imagine if you were condemned to the eternal return we discussed earlier, trapped in a loop of infinite repetition where nothing ever changes and nothing ever ends. That would be the true hell, a prison of boredom and meaninglessness. The heat death, the end of time, is what saves us from that prison. The fact that the universe has a lifespan means that this moment right now is unique. It has never happened before, and it will never happen again in the infinite history of the void. This perspective transforms our mortality from a curse into a gift. The philosopher Albert Camus imagined Sisyphus rolling his boulder up the hill only to watch it roll down again forever. But we are not Sisyphus because our hill has a top and our struggle has an end. The fragility of the stelliferous era, the brief window where life is possible, makes us the guardians of the rare and the beautiful. We are the universe's way of feeling emotion, of creating art, and of understanding itself. For a fleeting second in the long night, the fact that we will eventually be forgotten does not erase the fact that we were here. The music of our lives is not less beautiful because the song ends in silence. On the contrary, the silence frames the music, giving it shape and form, making every second of our conscious experience a victory against the nothingness. So, what do we leave behind when the clocks stop ticking and the last photon fades into the dark era? We leave behind the truth of our observation. In quantum mechanics, a system is undefined until it is observed by looking at the universe, by measuring the stars, and calculating the age of the Big Bang. We have forced the cosmos to take a shape. We have collapsed the wave function of reality from a haze of probability into a concrete history. Without us or beings like us, the universe would be a play. performed in an empty theatre with no audience to applaud or cry or understand the plot. Essentially, it would be indistinguishable from nothingness. We are the awakening of the cosmos. We are the stardust that organized itself into a brain capable of thinking about stardust. This is the ultimate strange loop of time that the universe created us, so that it could see itself through our eyes, even if all our books are burned and all our hard drives decay. The act of observation cannot be undone. The fact that the universe was known, that it was felt, and that it was loved by conscious minds is an indelible mark on the fabric of reality, a glitch in the entropy that can never be fully erased. Perhaps in the deep future, during the next Big Bang, or in the swirl of a baby universe, the information of our existence will leak through in the subtle patterns of the cosmic microwave background, or in the fine-tuning of the physical laws. We might be the ghosts in the machine of the next aeon, the ancestors of a timeline we will never see. So do not fear the end of time. Fear a universe that was never observed at all. We have done our job. We have opened our eyes, and for a brief, glorious moment, we have held the gaze of eternity and found that it was looking back at us. The paradoxes of time challenge everything we think we know about reality. They show us that the world is stranger, more fragile, and more wonderful than our intuition could ever tell us. We have journeyed from the speeding clocks of relativity to the frozen landscape of the quantum void, and we have stared into the face of the ultimate end. If this journey has made you feel dizzy small, or even a little scared, then it has succeeded, because that feeling is the sensation of your mind expanding to fit the true scale of the cosmos. If you want to continue this exploration of the impossible, if you want to peel back the layers of reality and confront the mysteries that lie beneath, then you are in the right place. This channel is dedicated to the hard questions, the scary theories, and the beautiful truths of science. So make sure you are subscribed and have the bell notification turned on, because in our next video we are going to tackle a subject even more elusive than time: the paradox of consciousness and the possibility that your mind is not in your brain at all. Until then, remember that while the universe may be winding down, your time is yours to spend. Do not waste it worrying about the heat, death, or the block universe. Use it to learn to create and to observe. Because in a universe destined for darkness, the simple act of understanding is the brightest light there is. Thanks for watching, and I will see you in the next one.